Alright, let's solve LeetCode number 1, two sums. So the problem is basically finding the target value using two numbers from given arrays list of numbers, and the sums of that two number will be equivalent to the target. If they're the same, then we will return the index value of that two number. So we will have two different type of solution. One is nested for loop. The term complexity is big O of n square, and the dictionary key value pair, the term complexity is big O of n. One is brute, one is non-brute, and we're going to use Python, Rust, and C. First, we're going to explore Python solutions. So the Python solutions for the brute force, just like we mentioned, the brute force require two for loop nested, and then we're going to compare the two value from the list, the given list number array or list numbers, right? So let's look at the main right here. Sorry, right here, this will be the given list of numbers 2, 7, 11, and 15, and then that will be the nums, so it will be list of integers, and yeah, we start comparing them. Oh, sorry, summing them, and then if the value is the same with the target, then that will be we will return their indexes. So this will be big O of n square, and it's very slow. For the more efficient or elegant solution is basically using key value pair. We're gonna subtract the target minus the current number from the list, and then we're going to get the complement. So we will check if it exists in the key value pair. If it's not exists, then we will use the current number as a key and the index value as a value. So that way, in the next number, if their complements exist in the key value pair data structures, then that will be the number we're trying to find, right? The matching. So that matching two value number will return their index value. Once the one that matched, the complement will be the key to find the index value of the matching number from the dictionary, and then the current index will be the match number, the other match number index value. So that will be our solutions for Python, and it's pretty elegant, very elegant, and is big O of n solutions. So for Rust, we're going to have to use hash for the dictionary key value pair. So for the brute, we don't have to use anything else other than vector, right? Instead of less, we're going to use vector, and the vector, the solution will be, the return solutions will be also the vector, and their type will be either return as an integer. And just like the brute from the Python, we use nested for loop and then return their index. For the non-brute solution, we have to use hash map from collections, and then basically, yeah, creating the dictionary, empty dictionary variable, and iterate through each number, and we use the index and the value to compare and find the complement. Once we found our complement index, we basically return their index number. So in this case, in Rust, we have to use sum for some optional, right? Just in case we couldn't find any matching number, then we use sum to handle it elegantly, right? So that doesn't explode it. So, and then we move on to the next value. So if we couldn't find any matching number, then we insert them in the dictionary. Yeah, and if nothing else is found, and we iterate through the list of numbers from the vectors, then we just basically return empty vector if there's no solutions. All right, that will be big O of n. Okay. For C, the brute solution is very simple, and just like Python, we just need to use two nested for loop and one if. and basically we use array. So in this case, pointer to nums, and we are saying that, hey, you don't need to change anything else, but just iterate through and compare the target versus the two numbers, right, and their sums, and return them once you found the result. And the result is basically we allocate the memory for two integer value, basically their index, right? So 0 and 1, and we assign them once we found their sums value is equivalent to the target. So for C, we have to manage the memory, just like here, the result malloc, right? We have to allocate. Down here, if we look at the solution, the main right here, so we pass the array and the target. That means we have to free them once if the result is found, then we have to free them right here. If we couldn't find the result, then there's nothing to be free. Just like any previous solution for non-brute, basically find the length and create the hash table, right, and then allocate the memory for the result and start finding the complement. And once we found our complement index, we return their index and free the hash table. And so for freeing the hash table, we have to check the table is really empty or not, right? If it's not empty, then we have to free the entries first, then the table. So finding the index, so the hash table will be the struct, right? And this is the key, and we have to use the while loop. So this is why big O of n for the time complexity for finding the index. And the -1 will indicate that the dictionary is empty. If it's not empty, then keep iterating, right? And then keep finding the hash key right here, the index, right? And this is how we're going to calculate the hash key, right? And basically try to find the hash key, the matching hash key. So once we found the hash key, then return the value of that hash key. Inserting, similar to basically call this function in our I think is the twosome right here, right? So for insertions, we have to basically insert using the hashing the key, and then insert. If it's not empty, then we're going to find a new hash key. If it's empty, then we're going to insert the key value pair. So this is how we're going to find the hash. So you can see the similar, right? The ABS key modulo to the size, right here, the table size. The plus one is the extra one that we needed to create the next hash number, so that it doesn't repeat the same hash key. Yeah. So in this case, it's just the hash functions. Here we create the table using malloc, and the entries, the empty hash, using malloc as well, and basically initialize them with the -1. So this will be the hash table structures, and the hash table entry structure, and this will be the hash table itself. All right. So now that you can puzzle together and you kind of understand how the dictionary, the fundamental of the dictionary is structured. Okay, so that's it.